Okay, I want to do a quick example on loops, showing a couple kinds of loops and how loops work in MATLAB. But the basic idea here is that a loop is a way to repeat a process as many times as you need it to solve a problem. So one kind of loop that's available in MATLAB is a for loop. In MATLAB, you can say for I equals 1 colon 10, display I, and everything between the for and the end gets repeated. So we're going to keep displaying I. And this for loop means I is going to go from 1 to 10. And since we didn't give it a middle value to tell it by how much, it's going to default to 1. So we run it, we go from 1 to 10. I could make this 20. We go from 1 to 20. I could make it from 5 to 22. And we'll go from 5 to 22. I could make it 5 to 15. Put in the middle 0.1. So we're going from 5 to 15 in increments of 0.1. So we start at 5, 5.1, 5.2, up to 14.1, 14.2, up to 14.9, and then 15. So it's pretty straightforward. You use a for loop when you want a variable to go from one value to another. One of the typical ways that we would use it would be to run through each value in an array if you need to. Or if you know a certain number of steps have to be executed, you can run through that number of steps. Now, we also have while loops. And a while loop is like an if statement, but where the statement inside gets repeated as long as the condition is true. So I'm going to try x equals 100 while x is greater than or equal to 0. Display x equals x minus 1, and end. And this is going to count down from 100 to 0. So if we save it and we run it, you can see we're counting down values till we get to 0. If I change this to x equals x minus 3, then we're going to count down by 3s. And you can see if we count down, we start at 100, 97, 94, we get down to 1. 1 minus 3 is negative 2, which is not greater than or equal to 0, so we don't display the negative 2. We never get into the loop. So these two commands in here get executed over and over again. Those are just the two ways to make a loop. And now I want to show quickly an example of a loop in practical terms. I'm going to read in the test move data CSV file that we had for MATLAB 7. And in that file, time was stored in position 1, or in column 1, and position was stored in column 2. So we're getting all the rows of column 1 and all the rows of column 2. And I'm going to just display the position here really quickly to verify that this worked, that we read it in. So we did, it's good. I still have the file uploaded in Octave. So those are the positions. Now, let's think if we only had the position of our Lego car, and we're trying to calculate the velocity and acceleration from the positions. Well, you can get velocity by getting the change in velocity divided by the change in time, or change in position divided by the change in time at each step. So I'm going to start with velocity of 1 being 0. That's something that'll in there because in order to get the change in velocity, we need to start at position 2. So we know our array is 125 elements long, so I could say for I equals 2 to 125. But instead, what I want to do is len equals length of the position array. That gives us the length command tells us how long that array is. We know that it's 125, so we could have just used 125 and this would be fine. But this way, no matter what length the array is that we get, it'll work because we're using the length command to figure out how many elements there are in the position array, and we're going to go look at each one of those elements. So, as we said, the calculating velocity is the change in position divided by the change in time. So the change in position is going to be the current position minus the previous position. So position I minus position I minus 1. The first time through it'll be position 2 minus position 1, then position 3 minus position 2. And the change in time will be time of I minus time of I minus 1. And then we can record the velocity at each step as delta P divided by delta T. Display the velocity. We run it. Node gives us velocities there. How about instead of displaying velocity, we plot the velocity. And we get this for the plotted velocity. Right? And this seems to be at least familiar to us, right? That it's basically motionless. It's a little jittery as it starts, then it accelerates pretty rapidly up to about 0.5 meters per second, and then it holds relatively constant, little ups and downs.